what's the limit of a to m plus 1 as m goes to infinity? Oh, I erased it. What did we say about our a? The a n were all positive. The a n were non-increasing. And the a n go to 0, right? Go to 0, right? So this is 0. Okay. So what you see is that S2m, the even partial sums converge to L, and the odd partial sums converge to L. Right? So the partial sums converge to L. Right? That is so the alternating series converges to L. Okay, so that's why the alternating series, if the terms are decreasing in magnitude, then the alternating series are always going to converge. Okay, that's why. Okay. Does it make sense? Anyone have questions about that? I think. Right. So remember what we're looking at. We're trying to see why something like this converges, right? A1 minus A2 plus A3 minus A4 plus A5 minus A6, etc. Why does that converge? And what we see is that, well, you end up with this sort of thing, right? It's going to be bouncing back and forth. The even partial sums are going to be increasing. The odd partial sums are decreasing. And the even guys and the odd guys converge to the same value. And so they converge. Right? So as you go onwards, it's going to start narrowing in on some number. That number is the limit. Later, we'll see that, so we were looking at this one, 1 minus a half plus a third minus a fourth plus a fifth minus a sixth, blah, blah, blah. Later, we'll see that this is actually the natural log of 2. We'll see that next week.
Mm-hmm.
Let me make one observation. Okay, so this is one thing that I should say. I don't have time to get into it, but how wrong is the nth partial sum? How wrong is the nth partial sum? How, like, if you sum up to S of n, how far are you from the real answer? How far are you from the real answer? Okay. So here's the picture again. Here is the first partial sum, the second partial sum, right? And to get there, we added on A2, right? Here's the third partial sum. To get there, we added on A3, right? Here's the fourth partial sum. To get there, we added on A4. Okay, so this distance, right? The distance between here and here is a absolute value of A1. Distance between here and here is the absolute value of A2. Distance between here and here is the absolute value of A3. And you see that, right? You see that Sn is at most absolute value of A sub n wrong. Right? Because the real answer is going to lie between these last two guys. Right? Here's S3, S4. The real answer lies somewhere in here. Right? The real answer lies somewhere between S3 and S4. And the distance between them is the absolute value of A4. Right? I'll draw the picture again. Right? Right? So we jump over to here. This is S1. We jump back this way. This is S2. The distance between these guys is absolute value of A2. Okay? Absolute value of A2. And we know that the answer is in here somewhere, right? Because after this, it's just going to bounce back and forth inside of here, right? So how wrong is S2? Well, it's at most A2 wrong, right? And we go here, S3, right? We know the answer is somewhere in here, and we know that this distance is the absolute value of A3, right? So how wrong is S3? Well, at most, it's A3 wrong, right? So this is an estimate on the error, right? The error for the nth partial sum is at most A sub n plus A sub n. In fact, you could say even A sub n plus 1, right? Because you know that it's between you and the next guy, right? You know that it's between you and the next guy. So it's maybe better to say A sub n plus 1. Anyway, if you get the idea with A sub n, that's fine. Does that make sense? Anyone confused by that? Right. We know that the actual answer is going to lie somewhere in here, right? So how wrong is S2? At most, it's A3 wrong, right? At most, S2 is A3 wrong. I should really say AN plus 1 because that's better, right? S2 is at most A3 wrong. Right, S3 is at most A4 wrong. Okay, that's it for today. So tomorrow we have a test. So it's basically the same thing as last time. It'll be a 1 hour test, and I think after that I'll probably just let you go. So 1 hour test, same format as before. There'll be some. There'll be some definition, there'll be some calculation, and there'll be some theory.